Roughly 400 million years ago, the seas entered a phase where vertebrate life began to reorganize itself. The Devonian stretched from roughly 419 to 359 million years ago. It is remembered as the age of fishes, though the phrase understates what was happening beneath the surface. This was not simply an increase in numbers. Bodies were being redesigned under pressure. Jawed fishes spread rapidly, and once animals could bite, slice, and crush, the balance of the ocean shifted with them. When predators improve, everything else must respond. Many of the dominant forms did not rely on speed alone. Their heads and front bodies were encased in dense bone, turning the leading half of the animal into both shield and weapon. These were the Placoderms, early jawed vertebrates, whose armor set them apart from anything alive today. At the same time, the seas were warm and full of life. Reef systems expanded across shallow waters, creating crowded environments where shelter, ambush, and competition existed side by side. Abundance did not make the ocean gentle. Some of these armored predators would later become icons of prehistoric life. Yet even now, their true size and dominance are not fully agreed upon. In this story, we look at the armored predators that defined the Devonian seas and the conditions that allowed them to rise before they were lost. Time settles into a quieter rhythm when placed within the long sequence of Earth's history, and the Devonian finds its place there with quiet certainty, following the Silurian and unfolding before the Carboniferous, a span that stretched from roughly 419 to 359 million years ago. It did not arrive suddenly, nor did it end in a single moment, but existed as part of a slow continuum in which oceans, land, and life reshaped one another in gradual, persistent ways. The world it belonged to would not be immediately recognizable, not in the arrangement of its continents, nor in the structure of its seas. Land masses that now sit far apart were drawn closer, clustered into forms that would later drift and fracture, while wide regions of the planet lay submerged beneath shallow waters that reached far inland. These waters, often described as epicontinental seas, spread gently across continental interiors, forming broad, sunlit environments where depth rarely reached extremes. Light filtered easily through these shallows, warming them, feeding the growth of marine life, and allowing ecosystems to expand across vast horizontal distances rather than plunging into darkness below. Coastlines were not sharp boundaries, but shifting gradients, where marine and terrestrial influences blended, creating lagoons, tidal flats, and sheltered basins that supported a diversity of life forms moving between stillness and motion. The warmth of the Devonian climate, combined with these expansive shallow seas, created conditions where biological activity could flourish without interruption across wide regions of the globe. In such environments, the physical structure of the sea itself became a participant in the story of life. Shallow marine shelves allowed organisms to anchor, burrow, filter, and build, leaving behind traces that would endure long after soft tissues faded. Sediment settled slowly, often preserving shells, plates, and skeletal fragments in layered records that now offer glimpses into this distant time. These conditions explain why the Devonian appears so vividly in the fossil record, not because life was only abundant, but because the settings in which it lived favored preservation. Hard parts accumulated, settled, and endured, turning ancient seafloors into quiet archives of vanished ecosystems. Yet the Devonian Ocean was never a single uniform expanse. It was a mosaic of habitats, each with its own character and constraints. Nearshore regions pulsed with movement and variation, shaped by tides and sediment. Reef systems rose in certain areas, forming structured environments where organisms clustered densely, while open shelves extended outward into broader waters where movement became more continuous and less confined. Deeper basins existed as well, though less illuminated, holding different communities adapted to dimmer, quieter conditions. Across these varied spaces, life distributed itself according to opportunity, pressure, and chance, creating a layered and interconnected system rather than a single shared experience of the sea. This diversity of settings allowed evolution to explore multiple paths at once. Organisms did not face a single environment, but many, each offering different resources, dangers, and forms of stability. Some adapted to still waters and soft sediments, others to structured reefs or open expanses where movement defined survival. The Devonian, in this sense, becomes less a singular ocean and more a network of marine worlds, each influencing the others while maintaining its own identity. Within this shifting arrangement of continents and shallow seas, the foundations were laid for the transformations already set in motion. The stage was not empty, but intricately prepared, shaped by geography, climate, and depth, allowing life to expand, compete, and specialize in ways that would leave lasting marks on the history of the ocean. There is a point in deep time when presence shifts from background to dominance, when a group once scattered across the margins begins to occupy the center of nearly every scene. During the Devonian, that shift settled around the fishes, not as a sudden arrival, but as a steady expansion that filled water after water with new forms, new movements, and new ways of living. Earlier seas had already carried vertebrates, but now they multiplied, diversified, and spread into roles that had once been rare or entirely absent, turning the age into something defined not by a single lineage, but by a broad and growing assembly. This transformation unfolded across many branches at once. Some retained older designs, jawless forms that moved through the water with slower, more constrained motions, lingering as echoes of earlier evolutionary stages. Around them, however, newer lineages pressed outward. Placoderms developed rigid coverings around their front bodies, combining protection with the ability to feed in ways that earlier vertebrates could not achieve. Alongside them, early sharks appeared with lighter frameworks, their bodies built for motion rather than weight, hinting at a different approach to survival. Ray-finned fishes extended delicate supports through their fins, allowing for precise adjustments in the water, while lobe-finned fishes carried thicker, more muscular appendages, their movements grounded in strength and control. Each of these groups explored a different solution to the same challenge: how to exist, move, and feed in a world where opportunities were expanding, but so were pressures. The seas of the Devonian did not offer a single path forward, and so evolution responded with variety rather than uniformity. Some bodies became streamlined, others compact and reinforced. Some mouths opened wide to take in prey whole, while others closed with force, capable of crushing or slicing. These differences were not decorative, but functional, each reflecting a specific way of interacting with the surrounding world. As these forms spread, their roles within marine ecosystems deepened. Fishes were no longer occasional participants within food webs dominated by invertebrates. They moved into positions where their actions shaped the behavior of other organisms, influencing where animals could feed, hide, or move. Their presence altered the rhythm of the water itself, introducing new patterns of pursuit and escape, of contact and avoidance. With greater diversity came a layering of interactions, where different species occupied different depths, speeds, and strategies, creating a more complex and dynamic system than before. This expansion did not remain confined to a single environment. From sheltered coastal waters to broader marine settings, fishes adapted to conditions that varied in clarity, depth, and structure. Some remained close to the substrate, Others ventured further into open spaces, and still others moved between zones, linking habitats that had once been more separate. In doing so, they became connectors within the ocean, carrying energy and influence across distances that extended beyond a single location. The phrase often used to describe this time, the age of fishes, rests not only on abundance, but on this quiet reorganization of life. Vertebrates that had once held limited roles became central to the functioning of marine ecosystems. Their diversity reflected an ongoing process, one in which anatomy, behavior, and environment interacted continuously, producing forms that seemed suited to their moment, even as the broader system continued to change around them. Through this gradual and persistent expansion, the Devonian seas came to be defined by fishes, not because they were the only inhabitants, but because their presence touched nearly every part of the marine world, shaping it in ways that would continue to unfold long after the age itself had passed. A small shift in structure can carry consequences far beyond its size, and in the Devonian seas that shift took form along the front edge of the head, where bone and cartilage aligned into a movable framework that could close with intent. Before this change, feeding remained limited by softness and suction, by the simple act of drawing food inward. With the emergence of jaws, that boundary loosened, and vertebrates gained the ability to meet the world with contact, to take hold rather than merely receive. The difference appears modest when held in isolation, yet within the wider system, it unfolded into something far more influential. The mechanics of jaws introduced new possibilities of action. Edges could meet and press, surfaces could grind, and opposing structures could work together to break apart material that once resisted consumption. Some mouths closed quickly, suited to capturing mobile prey in a brief encounter, while others applied slower, sustained force, capable of reducing harder bodies into manageable pieces. Teeth, when present, added further refinement, forming rows or plates that enhanced grip and cutting ability. Even in forms without true teeth, sharpened bony margins could serve a similar purpose, guiding the movement of prey and controlling its position once seized. These developments altered not only how animals fed, but what they could feed upon. Organisms that had previously existed with relative safety behind shells or rigid exteriors found themselves subject to new forms of interaction. Resistance no longer guaranteed survival, and so responses began to change. Some lineages thickened their coverings, others adjusted their shapes or behaviors, moving toward concealment, speed, or reproduction strategies that compensated for increased loss. The presence of jaws did not act in isolation, but as part of a growing network of cause and response, each adjustment in one group echoing through others. Within this network, pressure accumulated in subtle ways. A predator capable of gripping and processing prey efficiently could sustain itself with fewer failed attempts, increasing its influence within its surroundings. Prey species, in turn, faced a different landscape of risk, where encounters carried higher consequence. Over time, these interactions reshaped patterns of movement and habitat use. Sheltered spaces gained importance, open areas required different strategies, and the balance between exposure and protection shifted across many forms of life. Jaws also contributed to a change in pacing. Feeding events could become quicker or more decisive, reducing the time spent handling food and allowing for more frequent encounters. This efficiency did not create constant motion, but it introduced a new rhythm to the water, one in which the exchange between hunter and hunted became more direct. The sea did not grow louder, yet its interactions gained a sharper edge, shaped by contact rather than distance. Across the Devonian, This anatomical innovation spread through multiple lineages, each adapting it in its own way. Placoderms developed powerful biting surfaces integrated into their armored heads. Early sharks refined lighter, more flexible structures, and other fishes explored variations suited to their own feeding styles. The shared presence of jaws linked these groups, even as their designs diverged, creating a common thread that ran through an otherwise varied assembly. In this gradual unfolding, the introduction of jaws stands as a quiet turning point. It did not transform the ocean in a single moment, nor did it act alone, yet its influence extended through feeding, behavior, and ecological balance. A change at the scale of a mouth reached outward into the structure of entire communities, guiding interactions that would continue to evolve long after the first movements of bone and cartilage came together to close with purpose. Before movement is considered, the outline of these animals presents itself as a meeting of edges and planes, a body whose front seems assembled rather than grown, as if the leading half had been shaped into a continuous shield and set against the water. These were the placoderms, among the earliest jawed fishes, and for much of the Devonian, they stood as one of the most prominent vertebrate groups within both sea and inland waters. Their presence extended across regions and habitats, appearing not as a rare curiosity, but as a recurring form, varied in size and design, yet united by a distinctive approach to protection and structure. The most defining feature of these fishes lay in the arrangement of dense, bony plates that enclosed the head and the forward portion of the body. Instead of scales alone, the front of the animal carried interlocking armor, each plate fitting against its neighbors to create a rigid exterior that resisted deformation. These plates were not randomly placed, but organized into a functional system, forming a kind of articulated casing that surrounded vital regions while still allowing for necessary movement. Behind this armored section, the body often transitioned into a more flexible form, where softer tissues and smaller scales supported motion through the water. This combination created a contrast within a single organism, a front half shaped for resistance and interaction, and a rear half adapted for propulsion. It would be easy to imagine such construction as limiting, yet many placoderms show evidence of controlled and purposeful movement. Their fins, though varied across species, provided stability and direction, while the musculature of the unarmored regions allowed them to generate forward motion with consistency. Some forms likely moved with measured steadiness, others with greater bursts of speed, depending on their ecological role and body proportions. Within this range, certain placoderms occupied positions as active predators. Their jaws, integrated into the armored framework, could close with force, bringing together hardened edges that functioned effectively in capturing and processing prey. The presence of armor did not prevent engagement with other animals, but instead may have supported it, allowing these fishes to withstand impacts or resistance during feeding. The front of the body became both a point of contact and a protective barrier, merging offense and defense into a single structural concept. Placoderms were not confined to a single type of environment. Fossil evidence places them in marine settings as well as freshwater systems, suggesting an adaptability that allowed them to occupy lakes, rivers, and coastal waters alike. This distribution extended across multiple continents of the Devonian world, indicating that their design proved successful under a wide range of conditions. They were not isolated specialists, but participants in many ecosystems, interacting with different communities and contributing to the broader patterns of vertebrate life. Across these varied habitats, their forms diversified. Some remained relatively small, navigating quieter waters or specific niches, while others grew larger, their armored sections expanding in scale and complexity. Differences appeared in the shape and articulation of plates, in the arrangement of fins, and in the proportions of the body. These variations reflect a group exploring multiple paths within a shared framework, adapting the same basic construction to suit different roles and environments. In this way, placoderms represent more than a single type of fish. They form a broad and flexible lineage, one that combined early jawed structures with a distinctive approach to protection, creating bodies that could engage with the world in ways both direct and resilient. Their widespread presence and diversity mark them as a defining feature of the Devonian, a group whose armored forms moved through water that was itself becoming more structured, more interactive, and more demanding of those who lived within it. Weight settles first, long before motion becomes visible, and in an armored body that weight is carried forward, concentrated in plates that hold their form against pressure and contact. The presence of that mass does not remain neutral. It presses into every movement, every turn, every adjustment made within the water, shaping the way an animal begins to move even before it actually does. Balance becomes something negotiated rather than assumed, with the front of the body demanding stability, while the rest must respond, countering and guiding that load through fluid resistance. Protection, in this arrangement, is never free. The thickness of bone that shields vital regions adds durability, yet it also introduces inertia, a reluctance to change direction quickly or without effort. A body built this way carries momentum differently, favoring steadier advances over sudden shifts. Turning becomes a wider arc rather than a sharp pivot, and posture adjusts to maintain control, with fins and musculature working in coordination to keep the animal aligned as it moves. The water itself becomes a partner in this process, offering resistance that both stabilizes and constrains, depending on how force is applied. Within this balance, feeding must still occur. The armored front, while protective, also defines how the head can open, close, and position itself relative to prey. Movements near the mouth are guided by the structure of surrounding plates, limiting some motions while reinforcing others. Contact becomes more deliberate, less about flexibility and more about alignment, bringing the body into a position where force can be applied effectively. The act of feeding is therefore shaped by the same features that provide defense, merging the two into a single system rather than separating them into distinct functions. Breathing, though less visible, follows similar constraints. Water must pass across respiratory surfaces, and the flow required for this exchange depends on coordinated motion of the body and mouth. Armor alters how easily that flow can be generated, influencing the rhythms of opening and closing that draw water through. Subtle adjustments in posture and fin use help maintain this process, ensuring that the necessary exchange continues even as the animal moves or pauses within its surroundings. The body becomes a sequence of linked actions where protection, feeding, and respiration cannot be fully separated from one another. The silhouette that emerges from this design carries its own presence. The front appears defined and structured, with edges that catch and redirect water, while the rear remains more fluid, capable of bending and generating thrust. This contrast creates a visual and functional division, a body that seems anchored at one end and free at the other. Movement flows from back to front, with propulsion generated behind and guided forward into a controlled advance. The overall posture reflects this arrangement, often slightly angled or stabilized by fin placement, maintaining orientation while navigating through the surrounding medium. Behavior follows from these physical realities. An armored animal may favor approaches that align with its strengths, positioning itself where forward movement and controlled contact provide advantage. Encounters are shaped by the need to manage momentum, to approach rather than lunge, to meet rather than chase in every instance. At the same time, the protection offered by the plates allows a certain tolerance for interaction, reducing the cost of contact in ways that less protected bodies might not endure. The result is a way of existing that balances caution with capability, each movement informed by the structure that makes it possible. Through this interplay of weight, resistance, and control, armor becomes more than a covering. It defines the physical experience of the animal, influencing how it occupies space, how it meets the water, and how it engages with the living world around it. Along the front of certain armored fishes, a subtle seam interrupts the continuity of bone, a boundary where two rigid regions meet but do not fuse, allowing motion to emerge from what would otherwise remain fixed. This seam marks the defining feature of the arthrodires, a group within the broader Placoderm lineage that refined the relationship between protection and movement in a distinctive way. Within their bodies, the head shield and the trunk shield were connected not as a single solid casing, but through a joint that permitted controlled articulation, introducing flexibility into a form otherwise dominated by rigidity. This joint did not loosen the structure into softness. Instead, it created a precise point of motion where the front of the body could tilt or lift relative to the section behind it. The result was a controlled opening, a coordinated shift that allowed the head to move independently while still anchored to the rest of the body. In stillness, the animal retained the appearance of a continuous armored form, yet in action, that hidden division revealed itself, turning a static outline into something capable of sudden and purposeful adjustment. The implications of this design extended directly into feeding. When the head could move upward or forward against the resistance of the trunk, the mouth gained additional range, opening not only by the motion of the lower jaw, but through the coordinated movement of the entire front structure. This created a wider gape and a more forceful closing action, allowing prey to be engaged with a combination of reach and strength. The strike became a full-body event where the hinge served as a pivot, aligning armor, jaws, and motion into a single directed action. Such coordination suggests a body tuned for encounters that required both resilience and responsiveness. The protective plates still shielded vital regions, maintaining their role as a barrier against impact. Yet the joint ensured that this protection did not come at the cost of complete immobility. Instead, the animal could meet its surroundings with a controlled adjustment, shifting the orientation of its most important structures while keeping the rest of the body stable. This balance between firmness and flexibility allowed arthrodires to operate within a range of interactions that might otherwise have been restricted. Among these fishes, some forms reached considerable size, their armored sections expanding in scale while retaining the same underlying design. In such individuals, the hinge did not merely persist, it became an essential component of managing a larger and heavier front. Without it, the mass of the armor would have limited the ability to engage effectively, yet with it, the animal could direct that mass into movement, using the joint to guide the head into position with measured control. The larger the structure, the more significant this point of articulation became, shaping how the animal approached, aligned, and completed its actions. Beyond feeding, the presence of this joint influenced posture and general movement. The body could maintain a stable trajectory, while the head adjusted slightly to changes in direction or orientation, allowing for finer control within the water. This separation of functions, stability in one region and mobility in another, created a layered system of motion where different parts of the body contributed in distinct but coordinated ways. In this arrangement, arthrodires stand as a notable exploration in vertebrate design, not because they abandoned protection, but because they reworked it, introducing motion into a framework that might otherwise have remained fixed. The seam within their armor represents more than a structural detail. It reflects a solution to a broader challenge: how to remain protected while still engaging actively with a changing environment, shaping a form that carried both strength and adaptability within the same constructed surface. Recognition gathers around a single form more easily than around a crowd, and within the Devonian seas that focus often settles on Dunkleosteus, a name that has come to represent the image of an armored predator at its most imposing. Its outline is built around a broad, heavily plated head, a structure that seems less like a simple extension of the body and more like a solid front carried forward through the water. The surface of that armor curves and angles in ways that suggest both protection and intent, forming a forward edge that meets its surroundings directly rather than yielding to them. What defines Dunkleosteus most clearly lies not only in its size or its armor, but in the construction of its jaws. Instead of rows of separate teeth, the biting surfaces consist of sharpened bony plates, arranged so that their edges meet and slide against one another. As these edges wore down through use, their contact maintained a cutting surface, creating a system often described as self-sharpening. Each closing of the jaws reinforced their ability to slice and shear, allowing repeated use without the need for replacement structures. The motion of these plates, driven by strong musculature anchored within the armored head, produced a force that could act quickly and with considerable effect. The mechanics of this bite are often emphasized, not as a singular feature, but as part of a coordinated structure. The head, the joint behind it, and the jaw surfaces all align during feeding, bringing mass, motion, and edge together in a single action. This coordination gives the impression of efficiency, where each component contributes to the outcome without excess movement. The animal does not rely on prolonged handling, but on decisive contact, using the strength of its construction to complete the interaction in a controlled and directed manner. Over time, this combination of features has shaped how Dunkleosteus is imagined, often placing it among the largest and most dominant predators of its age. Early interpretations suggested substantial body lengths, extending far beyond the already formidable head, creating a vision of a giant moving through Devonian waters with unmatched scale. More recent work, however, has revisited these estimates, examining the relationship between known skull material and the rest of the body. Some studies propose that earlier reconstructions may have extended the proportions too far, and that the full body length could have been more moderate than once believed. This adjustment does not diminish the presence of the animal. Instead, it refines the image, bringing it closer to the limits supported by available evidence. The skull remains large, the jaws remain powerful, and the overall form retains its distinctive character. The revision shifts attention away from exaggerated scale and toward the details that can be observed directly, emphasizing structure and function rather than sheer magnitude. In this way, Dunkleosteus becomes not less impressive, but more precisely understood, its influence grounded in what can be known rather than what was once assumed. Within this evolving understanding, the animal continues to occupy a central place in discussions of Devonian life. Its fossil remains, often dominated by the armored head, provide clear and tangible evidence of its design, while the rest of its body invites careful reconstruction. Each new analysis contributes to a more nuanced view, where certainty and uncertainty coexist, guiding interpretations without fixing them entirely. Dunkleosteus, then, stands as both a presence within its ancient environment and a subject of ongoing study, its image shaped by the interplay between fossil evidence and scientific revision. Its enduring recognition reflects not only the strength of its design, but also the way knowledge itself develops, gradually refining the forms that once moved through seas long since transformed. Attention often settles on a single figure, yet the waters of this time held a wider presence, one that cannot be contained within a lone outline or name. The armored forms that moved through these seas did not belong to a solitary lineage dominating in isolation, but to a broad and varied assembly, a dynasty composed of many shapes, many sizes, and many ways of living. What appears, at first glance, as a single, powerful archetype unfolds into a distributed presence, extending across habitats and ecological roles, filling the Devonian with layered expressions of the same underlying idea. Across this spread, size alone offered no simple pattern. Some armored fishes remained relatively small, their bodies adapted to quieter corners of their environments, where movement could be measured and interactions limited. Others grew larger, their proportions shifting as their ecological positions changed, carrying more mass and presenting a greater physical presence within the water. Between these extremes existed a continuous range, where variation did not separate one form entirely from another, but instead created a gradient of bodies, each occupying a slightly different place within the same shared world. Feeding styles followed a similar diversity. Certain species appear suited to capturing smaller, softer prey, using controlled movements to bring food into reach without the need for forceful engagement. Others developed structures capable of handling more resistant material, their biting surfaces and head configurations aligned to apply pressure where it was needed. Some may have operated as generalists, adapting to available resources, while others took on more specialized roles, focusing on particular types of prey within their environment. This variation in feeding reflects a broader pattern, where no single approach defined the group, but many coexisted, each supported by differences in anatomy and behavior. Habitat use further expanded this range. Armored fishes occupied coastal zones, where conditions could shift with tides and sediments, as well as more stable marine settings beyond immediate shore influence. Some extended into freshwater systems, moving through rivers and lakes where the surrounding conditions differed from those of the open sea. This distribution suggests a flexibility not limited to one environment, but capable of spanning multiple types of water, linking different ecological spaces through shared presence. The dynasty did not confine itself to a single domain, but spread wherever conditions allowed its designs to function. Within this spread, interactions multiplied. Different armored forms encountered one another, as well as other inhabitants of their environments, creating networks of contact that varied from place to place. No single species defined these interactions entirely. Instead, the combined presence of many contributed to a broader pattern, where armored fishes as a group influenced the structure and behavior of surrounding communities. Their impact emerged not from a single dominant individual, but from the accumulation of many forms acting within overlapping systems. The idea of rule, when applied here, takes on a quieter meaning. It does not describe a singular authority, but a sustained influence distributed across space and time. Armored fishes shaped their environments through persistence and variety, through the repeated presence of bodies built on similar principles, yet expressed in different ways. Their dominance lay in this collective presence, in the way they occupied multiple niches and maintained their roles across changing conditions. Seen in this light, the Devonian becomes less a stage for one towering figure and more a field of related forms, each contributing to a shared identity without erasing its own distinctiveness. The dynasty of armored fishes emerges not as a single line, but as a network, one that extended across waters and habitats, leaving behind a record of diversity that speaks not to isolation, but to widespread and enduring influence. Beneath the passage of these armored bodies, the seafloor did not lie flat and empty, but rose in layered structures that gathered life into dense and intricate communities. Across many regions of the Devonian, reefs expanded into broad formations, not as single walls or isolated patches, but as living frameworks built slowly through accumulation. These structures formed where conditions allowed growth to persist over long spans of time, creating environments that stood apart from surrounding sediments, offering both elevation and complexity within the water. The builders of these reefs worked without motion in the familiar sense, yet their presence shaped entire habitats. Corals extended their forms outward, each individual adding to a larger network of connected bodies. Alongside them, stromatoporoids contributed thick, layered masses, their growth forming solid foundations that resisted erosion and supported further expansion. Algae, often less visible in the fossil record, played a quiet role, binding surfaces and stabilizing the growing structure. Together, these organisms created a framework that was neither purely biological nor purely geological, but something that existed between the two, a living architecture assembled through countless small additions. Within these formations, space became varied and segmented. Cavities opened between layers, narrow passages formed where growth intersected, and sheltered pockets developed in areas protected from stronger currents. Light reached some surfaces more readily than others, shaping where different organisms could settle and thrive. This variation created gradients of exposure and protection, allowing a wide range of life forms to occupy positions suited to their needs. Some clung to exposed surfaces, filtering particles from the water, while others remained hidden within the interior spaces, moving carefully through confined channels. For animals capable of movement, these reefs offered more than structure. They provided opportunities. Shelter could be found among the openings, allowing smaller organisms to avoid direct exposure. Nursery spaces emerged in protected zones where early stages of life could develop with reduced disturbance. At the same time, the same features that offered protection also created points of encounter. Narrow passages guided movement, bringing animals into proximity, while edges and overhangs provided positions from which others could observe and act. Predators, moving through or around these environments, encountered a landscape that shaped how they approached their interactions. The presence of solid structures limited direct paths, encouraging movement along edges or through defined routes. Encounters became influenced by the layout of the reef itself, with contact often occurring where pathways converged or where open spaces met enclosed ones. The environment did not dictate behavior entirely, yet it framed it, providing boundaries and opportunities that influenced how movement unfolded. These reef systems also acted as centers of productivity. The organisms that built and inhabited them contributed to a continuous exchange of material and energy, supporting food webs that extended beyond the immediate structure. Particles captured at the surface moved inward, waste settled into lower regions, and smaller organisms fed upon what accumulated, creating a layered system of consumption and renewal. This concentration of life made reefs focal points within the broader marine environment, areas where activity gathered and interactions intensified. In this setting, the presence of larger, more capable predators found context. Their movements and actions were not carried out in open emptiness, but within environments that offered both resistance and opportunity. The reef provided surfaces to navigate, spaces to enter or avoid, and positions from which encounters could be shaped. In this way, the structure of the environment became part of the interaction itself, influencing outcomes through its form. Through the steady growth of corals, stromatoporoids, and associated communities, the Devonian seas developed not only inhabitants, but architecture. This living framework supported a diversity of roles and relationships, creating spaces where life could gather, persist, and interact within a shared structure that extended across regions and endured through time. Across the Devonian waters, structure did not belong to a single group, but emerged from countless bodies that carried their own forms of protection, each contributing to a seafloor that felt assembled rather than empty. Movement passed over a landscape already shaped by living materials, where shells, plates, and skeletal frameworks accumulated and overlapped, creating a world in which hardness was not an exception but a common condition. The presence of vertebrate armor existed within a broader field of resistance, one built largely by invertebrates whose bodies left lasting traces. Brachiopods rested in large numbers across the substrate, their paired shells opening and closing in steady rhythms as they filtered what drifted through the water. Their forms varied, some smooth and rounded, others marked by ridges that caught sediment and light, creating subtle textures across the seafloor. Trilobites moved among them, their segmented bodies carrying a different kind of structure, articulated plates that allowed controlled movement while maintaining protection. Their presence added motion to the otherwise settled layers, small shifts and adjustments that traced pathways between more stationary forms. Crinoids extended upward from the substrate, anchored below and branching above into delicate arrays of feeding arms. Though their bodies were composed of numerous small skeletal elements, together they formed a continuous structure, rising into the water column and contributing vertical complexity to the environment. Around and among them, mollusks of various kinds occupied both the surface and the spaces between, some enclosed within coiled shells, others moving along the substrate, each adding to the layered composition of life. This abundance of hard parts did not occur by chance. The conditions of the Devonian seas supported the development and persistence of mineralized structures, allowing organisms to build shells and skeletons that resisted decay and deformation. Over time, these materials accumulated, settling into sediments that preserved their forms long after the organisms themselves were gone. The fossil record reflects this accumulation, not because soft bodies were absent, but because hard structures endured, recording a world in which physical form played a central role in survival and interaction. Within this environment, the distinction between living organism and surrounding structure often blurred. Shells became surfaces for other organisms to attach. Skeletal fragments contributed to the formation of new layers, and the remains of past life supported the present. The seafloor evolved into a composite surface, built from generations of organisms whose hard parts interlocked and overlapped, creating a continuity that extended beyond individual lifespans. Against this background, the armored vertebrates introduced earlier did not stand alone in their use of protection. Their plated forms existed alongside a multitude of invertebrates that also relied on hardness, though expressed in different ways. The difference lay not only in material, but in function and movement. While many invertebrates remained fixed or slow-moving, their shells serving primarily as barriers and supports, the vertebrates carried their armor into active interaction, combining protection with motion. This contrast created a layered system of defenses, some static, others dynamic, all contributing to the overall character of the environment. The result was a sea that felt physically substantial, where contact with the substrate or with other organisms often meant encountering resistance. Softness existed, but it was interwoven with firmness, creating a balance that shaped how life moved and settled. The abundance of shells, spines, and skeletal elements introduced textures and boundaries that influenced movement, feeding, and interaction across many forms. In this setting, the Devonian Ocean becomes more than a collection of inhabitants. It becomes a constructed space where life itself provides the materials that define its own environment. The accumulation of hard parts, layered over time, forms a foundation upon which further life develops, creating a continuity that links past and present within the same structured world. Far from the structured surfaces below, new forms began to trace gentle arcs through the water itself, their movement guided less by contact and more by balance, as if held in place by the surrounding medium rather than anchored to it. Among these were the early Ammonoids, appearing during the Devonian as a distinct lineage that carried forward a heritage rooted in older nautiloid ancestors. Their presence did not replace what came before, but refined it, altering shape and function in ways that allowed a different relationship with the open water. The most visible change lay in the shell. While earlier relatives often bore straighter or more loosely curved forms, these newcomers developed tighter coils, winding their shells into compact spirals that gathered volume around a central axis. This coiling was not simply a matter of appearance. It reorganized how the body was supported and balanced, placing mass in a way that made orientation within the water more stable and responsive. The shell became both structure and instrument, influencing how the animal drifted, rose, or settled within its surroundings. Inside these shells, a series of internal chambers formed, separated by thin walls and connected by a narrow tube. Through this system, the animal could adjust the balance between gas and fluid, subtly altering its buoyancy. This capacity allowed it to occupy different depths without constant exertion, maintaining position within the water column with a degree of control that earlier forms had only begun to explore. Movement no longer depended solely on contact with the seafloor or continuous swimming, but could include periods of suspension where the animal remained poised within the water itself. This shift carried wider implications. By enabling more efficient control over vertical position, ammonoids could access spaces above the substrate that were less crowded and more open. These regions offered different resources and interactions, extending the range of available habitats beyond those defined by surfaces and structures. The water column became more than a space to pass through. It became a place to inhabit, with its own layers, each presenting distinct conditions of light, pressure, and movement. Within these layers, life began to distribute itself in new ways. Some organisms remained close to the bottom, others occupied intermediate depths, and still others moved more freely through open water. The presence of ammonoids contributed to this growing complexity, adding mobile, buoyant forms that interacted with both lower and higher regions. Their movements connected different parts of the environment, creating pathways of interaction that did not rely on fixed locations. The coiled shell also influenced how these animals moved horizontally. Its compact form reduced drag compared to more extended shapes, allowing smoother passage through the water. Combined with jet propulsion, produced by expelling water through a siphon, ammonoids could navigate with controlled bursts, adjusting direction and speed as needed. Their movement was not constant, but measured, alternating between active propulsion and passive drifting, each phase supported by the structure of the shell. As these forms spread, they became part of a broader transformation within the ocean. The open water, once less densely occupied, began to fill with organisms capable of sustained movement and controlled positioning. This expansion introduced new relationships where encounters could occur away from the seafloor and where interactions were shaped by depth as well as horizontal distance. The ocean gained a vertical dimension of activity, adding complexity to an already varied system. In this unfolding, ammonoids serve as an entry into a wider change, one where life increasingly occupied the spaces between surfaces. Their shells, coiled and chambered, allowed them to balance within the water, moving with a combination of control and drift. Through this design, they participated in the gradual transformation of the ocean into a layered environment, where motion and position extended beyond the boundaries of the substrate and into the open expanse above. A gradual lifting began, not of land or water, but of life itself, as more bodies moved away from surfaces and into the open spaces between. This change, often described as the Devonian Nekton Revolution, did not occur as a sudden shift, but as a steady increase in animals capable of sustained, directed movement through the water. Where earlier communities had been largely defined by organisms resting on the seafloor or drifting with currents, a new pattern emerged, one in which many forms actively navigated their surroundings, choosing direction, speed, and depth with growing precision. This transition altered how presence was distributed. The bottom remained populated, its layered structures still supporting a wide range of life, yet above it, the water itself began to fill. Bodies no longer needed to remain in contact with a surface to function. Instead, they occupied positions suspended within the surrounding medium, moving through it with intention rather than passivity. The difference lay not only in motion, but in control. Drifting gave way to swimming, and with it came the ability to approach, avoid, and respond in ways that had not been widely possible before. As more animals entered this space, the relationships between them shifted. Encounters were no longer limited to fixed locations or predictable pathways along the substrate. They could occur at varying depths, along changing trajectories, and at speeds that altered the timing of interaction. This introduced a new level of complexity to food webs, where connections extended vertically as well as horizontally. Predators could pursue prey through open water, while prey developed ways to evade, adjust, and reposition themselves within a three-dimensional environment. Pursuit itself became a more dynamic process. Instead of relying solely on proximity or ambush from fixed points, hunters could follow, track, and close distance over time. This required coordination between body form and movement, as well as the ability to maintain orientation within a fluid and shifting space. At the same time, those being pursued adapted in response, developing strategies that took advantage of speed, maneuverability, or changes in depth. The interaction between hunter and hunted became less about a single moment of contact and more about a sequence of movements unfolding across space. With this change came new demands on perception. Detecting another organism in open water required sensitivity to movement, pressure, and subtle variations in the surrounding environment. Visual systems became more important where light allowed, while other senses contributed to awareness beyond immediate contact. The ability to locate, track, and anticipate became as significant as the ability to move, linking sensory capacity with physical action in a continuous process. The expansion into the water column also influenced how energy moved through the ecosystem. Food resources were no longer confined to surfaces or drifting particles, but could be accessed and transferred across different depths. Organisms occupying intermediate layers connected those below and above, creating pathways that linked previously separate parts of the environment. This integration contributed to a more interconnected system where changes in one layer could influence others. As these patterns developed, the overall character of the sea shifted. Movement became more frequent, interactions more varied, and the space itself more fully occupied. The presence of active swimmers introduced a sense of constant adjustment, where positions and relationships changed over time rather than remaining fixed. The environment did not lose its structure, but gained a new dimension of activity layered upon it. Through this gradual expansion, the Devonian Ocean took on a different quality. Life extended into the spaces between surfaces, filling them with motion and interaction. The result was a marine world shaped not only by where organisms rested, but by how they moved, creating a system in which activity and presence were distributed throughout the water itself. Another lineage begins to take shape within these same waters, not by adding more mass to the front of the body, but by reducing weight and redistributing strength into a different kind of framework. Early cartilaginous fishes emerged during the Devonian, their skeletons built from cartilage rather than dense bone, giving them a lighter internal structure that changes how they move, how they turn, and how they sustain motion over time. Their presence does not replace the armored forms already established, but it adds a parallel approach to survival, one that operates according to different constraints and possibilities. The bodies of these early sharks and shark-like fishes appear more continuous from front to back, without the same abrupt transition between rigid and flexible regions. Their outlines flow more smoothly, allowing the entire form to participate in movement rather than concentrating motion in specific sections. Fins extend outward as stabilizers and guides, while the tail generates propulsion in a steady, repeating rhythm. This arrangement supports a style of swimming that favors consistency and endurance, where motion can be maintained over longer distances with less interruption. Weight, in this design, is distributed differently. Without heavy external plates, the body interacts with the water in a way that emphasizes responsiveness. Turns can be executed with less resistance, adjustments made more readily, and changes in direction carried out with smaller shifts in force. The animal becomes less anchored by its own structure and more integrated with the fluid medium around it, responding to currents and opportunities with a degree of flexibility that contrasts with heavier forms. Feeding follows this pattern of integration. The jaws of these fishes, though varied in shape and function, operate within a framework that allows repeated opening and closing without the constraint of rigid surrounding plates. Teeth, when present, form rows that can be replaced over time, maintaining effectiveness even as individual elements wear down. This system supports ongoing interaction with prey, where capture and processing can occur in sequence rather than through a single decisive action. The emphasis shifts from one moment of force to a series of controlled engagements. Within the broader marine system, these cartilaginous fishes occupy roles that overlap with those of armored predators without mirroring them exactly. They move through similar spaces, encounter similar prey, and contribute to the same network of interactions, yet they do so through different means. Their lighter construction allows them to navigate open water with ease, while their sensory systems, attuned to movement and disturbance, support detection across distances that extend beyond immediate contact. In this way, they participate in the evolving dynamics of the Devonian seas, adding another layer to an already complex arrangement. The presence of these fishes introduces a quiet form of comparison. Two approaches exist side by side, one emphasizing protection and concentrated force, the other favoring mobility and sustained motion. Neither replaces the other within this period, and both find ways to persist within shared environments. Their coexistence suggests that the conditions of the time could support multiple solutions, each effective under different circumstances, each contributing to the overall structure of marine life. As the Devonian continues, these cartilaginous fishes remain part of the unfolding story, their forms extending into habitats that range from nearshore regions to more open waters. Their lineage carries forward beyond this period, not as a sudden dominance, but as a continued presence that adapts and persists. Within the moment itself, they stand not as successors, but as contemporaries, moving alongside armored bodies through a sea that accommodates both weight and lightness, both rigidity and flow, without yet resolving which approach will endure longer. A body meets the water in one of two broad ways, either by resisting it or by yielding to it, and within the Devonian seas, both approaches moved side by side, each carrying its own advantages and limits. Some forms pressed forward with reinforced fronts, their surfaces designed to endure contact and absorb force, while others slipped through the water with lighter frames, relying on motion itself as their primary means of engagement. These were not opposites in conflict, but parallel strategies unfolding within the same environment, each shaped by the demands placed upon it. Protection offered a certain kind of stability. A body built to withstand impact could approach interactions with less immediate consequence, its structure providing a buffer against resistance. Movement in such forms often carried a sense of momentum, a continuation once set in motion, where changes in direction required planning and space. The surrounding water supported this by smoothing motion over time, allowing steady advances that did not rely on sudden bursts. In this approach, the body becomes a presence that holds its course, meeting the world with firmness rather than speed. In contrast, lighter forms distributed their strength through motion. Without the burden of heavy external structures, they could respond quickly to changes, adjusting direction with smaller shifts in force. Acceleration became a central feature, allowing rapid engagement or withdrawal as conditions required. The body curved and flexed along its length, transferring energy through waves of motion that propelled it forward. This style favored continuity, where movement could be sustained or altered with minimal delay, creating a fluid relationship with the surrounding medium. These differences extended into how each form navigated space. Heavier bodies tended to follow broader paths, their turns wider, their adjustments more gradual. They occupied routes that allowed for controlled alignment, where encounters could be managed through positioning rather than sudden change. Lighter bodies moved along more varied trajectories, capable of weaving through openings, shifting depth, and redirecting their path in response to subtle cues. The same environment offered different possibilities depending on how a body interacted with it. Energy use also diverged between these approaches. Maintaining motion over time required different investments depending on structure. A heavier form might rely on shorter periods of movement interspersed with stability, conserving effort through its ability to endure contact. A lighter form, built for sustained swimming, could maintain activity for longer durations, its efficiency tied to the rhythm of its motion. Neither approach existed without cost, and each balanced its energy use against the benefits it provided. Within the broader system, these strategies did not exist in isolation. They overlapped in space and time, contributing to a dynamic arrangement where different forms influenced one another. Encounters between them reflected their respective designs, with outcomes shaped by how protection and mobility interacted in specific moments. The environment itself, with its varied conditions, supported both approaches at once, offering spaces where each could function effectively. Over longer spans, conditions could shift, altering which strategy held advantage in a given setting. Changes in habitat structure, resource distribution, or the presence of other organisms influenced how protection and mobility were valued. A design suited to one set of circumstances might find itself challenged under another, while alternative forms adapted more readily. This ongoing adjustment created a balance that remained in motion, never fixed, always responsive to the surrounding world. In this interplay, the Devonian seas carried a quiet comparison between different ways of being effective within the same environment. Bodies built for endurance and contact moved alongside those shaped for speed and flexibility, each representing a distinct solution to the same underlying challenge of survival within a shared and ever-changing system. Along the shifting boundary where land met sea, the water did not settle into a single form, but broke into a mosaic of shallow basins, channels, and quiet inlets, each shaped by tides, sediments, and the slow rearrangement of coastlines. These nearshore regions carried a different character from the broader marine spaces, less open, more variable, and often more enclosed, creating conditions that favored a distinct kind of biological activity. Within these environments, early vertebrate life found not only space to exist, but opportunities to change. Coastal waters moved in rhythms set by both ocean and land. Tides drew water inward and outward, exposing and covering surfaces in a steady cycle, while freshwater inputs from rivers altered salinity and carried nutrients into the system. Lagoons formed behind natural barriers, their waters calmer and often warmer, creating sheltered zones where smaller organisms could persist with reduced disturbance. Estuaries blended freshwater and marine conditions, producing gradients that shifted over short distances, requiring adaptability from those that lived within them. Along shelf margins, the transition from shallow to deeper water introduced further variation, linking nearshore complexity with the broader marine environment. Within this network of habitats, complexity arose not from a single structure, but from constant change. Sediments settled and were disturbed, channels opened and closed, and water conditions varied with time and location. These fluctuations created a setting in which stability was never complete, and organisms were required to respond to shifting conditions. For early vertebrates, this variability may have acted as a catalyst, encouraging the development of forms and behaviors capable of handling a wider range of circumstances. The diversity of microenvironments within nearshore regions allowed different strategies to emerge side by side. Some areas offered protection, with limited exposure to currents or larger predators, while others presented more open conditions where movement and awareness were essential. This variation supported experimentation in body form, feeding, and locomotion, as organisms adapted to specific niches within a broader system. The proximity of these niches meant that transitions between them were possible, allowing lineages to expand or shift their roles over time. In such settings, early vertebrates could explore new ways of interacting with their surroundings. Shallow waters made contact with the substrate more frequent, while changes in depth and clarity influenced how movement and perception functioned. The presence of vegetation or structured surfaces added further complexity, creating spaces that could be navigated, used for shelter, or exploited for feeding. Each of these elements contributed to an environment where innovation could occur incrementally, shaped by immediate conditions rather than distant pressures. The intimacy of these habitats contrasts with the broader scale of the open sea. Here, distances were shorter, boundaries more defined, and interactions often more localized. This allowed for a closer relationship between organism and environment, where small changes in form or behavior could have noticeable effects. Over time, these adjustments accumulated, contributing to the diversification of vertebrate life in ways that extended beyond the nearshore regions themselves. These areas can be understood as evolutionary workshops, not in the sense of deliberate design, but as spaces where variation was continually tested against changing conditions. The results of these processes did not remain confined to the coast. As forms proved effective, they could move outward, carrying with them adaptations shaped in these more complex settings. Within the quiet movement of coastal waters, the foundations of many vertebrate stories took shape. The interplay of tides, sediments, and shifting boundaries created a setting where life could explore new possibilities, gradually expanding its range of forms and functions. These nearshore environments, often overlooked in favor of more dramatic scenes, held a steady influence, shaping the early pathways of vertebrate evolution through their persistent and varied conditions. Perception begins before movement, in the faint disturbances that travel through water long before bodies meet. And within the Devonian seas, those disturbances carried information that shaped every encounter. The presence of structured habitats and suspended particles altered how signals moved, bending light, diffusing motion, and creating a world where detection depended on more than a single sense. Predators navigating these conditions did not rely on direct sight alone, but on a layered awareness built from multiple inputs, each contributing to a continuous understanding of what lay nearby. Vision remained important where light could penetrate, though it rarely arrived without alteration. Particles drifting through the water scattered and softened what could be seen, turning outlines into shifting forms rather than fixed shapes. Objects at a distance lost clarity, their edges dissolving into the surrounding medium. Within reef environments, light filtered unevenly, broken by structures and surfaces that cast overlapping shadows. In such settings, sight functioned best at closer ranges, where detail could still be resolved and movement distinguished from background motion. Alongside vision, another form of sensing operated through the body itself, a sensitivity to changes in pressure and flow that allowed detection without direct contact. Channels embedded along the sides of fishes, often described as lateral line systems, responded to subtle movements in the water, registering the passage of other organisms or the disturbance created by their actions. This sense extended beyond the limits of sight, offering information about direction and proximity even when visibility was reduced. A passing body, a sudden shift, or a pulse of movement could be perceived as a change in the surrounding fluid, guiding attention toward its source. Water movement itself became a signal, carrying traces of activity across short distances. Currents interacted with structures, creating patterns that could be read by those attuned to them. A steady flow might indicate open space, while irregular turbulence could suggest the presence of obstacles or organisms. Predators moving through such environments likely adjusted their behavior in response to these cues, positioning themselves where detection was more reliable and movement more predictable. Close-range encounters relied on a convergence of these senses. As distance closed, visual detail increased, pressure changes became more distinct, and the combined information allowed for a more precise assessment of position and timing. The moment of engagement depended on this alignment, where detection transitioned into action. Armor, while providing protection and structure, did not determine the outcome on its own. A successful hunter required the ability to locate and track, to distinguish between background and target, and to coordinate movement with perception in a seamless sequence. Ambush strategies may have developed within environments where structure provided concealment. A predator positioned within or near complex surfaces could remain partially obscured, relying on sensory input to detect approaching prey. Movement would then be initiated at a moment when distance and alignment favored contact. In more open settings, pursuit relied on continuous sensing, maintaining awareness of a moving target through shifting conditions and adjusting trajectory accordingly. Each approach reflected a different balance between stillness and motion, yet both depended on the same underlying capacity to perceive. These sensory processes shaped behavior in ways that extended beyond individual encounters. The ability to detect influenced where organisms could move, how they approached environments, and how they interacted with others. Areas with clearer signals might support more active movement, while regions of greater interference encouraged caution and positioning. Over time, these patterns contributed to the distribution of life within the water, linking perception with habitat use and ecological role. Within this layered sensory world, the Devonian Sea became a place where information flowed continuously through the medium itself. Light, pressure, and motion combined to create a dynamic field of signals, guiding the actions of those capable of reading them. The hunter, shaped by armor and movement, remained equally shaped by this constant exchange, its success defined not only by strength or structure, but by its ability to sense, interpret, and act within a world that revealed itself through subtle change. Feeding leaves its signature not only in what is eaten, but in the shapes that bodies take to make that eating possible. And across the Devonian waters, those shapes varied in ways that reveal a quiet diversity of purpose. Mouths did not follow a single pattern. They formed into different arrangements, each aligned with a particular kind of interaction, each reflecting the kinds of materials that could be taken, held, or broken apart. The result was a landscape of feeding strategies expressed through structure, where the form of the mouth became a direct extension of the role an organism played. Some designs concentrated force into surfaces capable of crushing. Broad, reinforced edges met resistant prey with steady pressure, bringing shells and rigid coverings into contact with structures that could withstand and overcome their strength. These forms did not rely on speed alone, but on the ability to apply controlled force over a short distance, breaking apart materials that would otherwise remain intact. The bodies that carried such mouths often aligned their movements to support this action, positioning themselves to bring prey into contact where pressure could be applied most effectively. Other forms emphasize slicing, arranging their biting surfaces into edges that could shear through softer tissues or divide more resistant material along lines of weakness. These mouths operated through motion as much as force, guiding prey across surfaces that cut as they closed. The interaction became a combination of alignment and movement, where the orientation of the head and the path of closure determined the outcome. In these cases, feeding depended on bringing edges into contact with precision, allowing structure and motion to work together. A different approach emerged in suction feeding, where the mouth functioned less as a tool of contact and more as a conduit for drawing in surrounding water and whatever it carried. Rapid expansion of the oral cavity created a pressure difference that pulled prey inward, reducing the need for direct grasping. This method favored smaller or more mobile organisms that could be captured through proximity rather than resistance. The body supported this action by coordinating opening, expansion, and closure in a sequence that moved fluid and prey together into the mouth. Alongside these more specialized forms existed generalist feeders, whose mouth structures allowed for a range of interactions rather than a single, focused method. Their designs did not excel in one extreme, but provided flexibility, enabling them to take advantage of varying food sources depending on availability. This adaptability allowed them to occupy roles that shifted over time, responding to changes in the surrounding environment without requiring a complete restructuring of their bodies. Each of these feeding strategies mapped onto different kinds of prey. Shell-bearing organisms encountered crushing forms that could break their defenses, while softer-bodied animals faced slicing edges or suction-based capture. The distribution of prey influenced which strategies proved effective, and in turn, the presence of those strategies shaped the evolution of prey themselves. Over time, this interaction created a network of responses where changes in one group led to adjustments in another, linking the structure of mouths to the broader development of the ecosystem. This diversity of feeding mechanisms contributed to a system in which no single approach dominated entirely. Instead, multiple strategies coexisted, each supported by specific conditions and interactions. The Devonian seas became a place where different ways of processing food existed side by side, forming a complex arrangement that reflected both opportunity and constraint. Within this arrangement, the mouth emerges as more than an anatomical feature. It becomes a point where structure, behavior, and environment converge, shaping how organisms engage with one another and with the materials that sustain them. The variety of forms present during this time suggests a process of continual exploration where different solutions were tested and refined across a shared and changing world. Pressure does not always announce itself through sudden force. It can settle slowly into the routines of daily existence, shaping behavior through repeated encounters until the environment itself feels different. In the Devonian seas, as larger jawed fishes became more common, this kind of pressure spread across many forms of life, altering how organisms moved, where they remained, and how they persisted over time. For those that lived under this growing presence, survival became less about a single moment and more about a continuous adjustment to conditions that no longer allowed stillness without consequence. Bodies responded first through structure. Shells thickened or took on new shapes, curving and reinforcing in ways that distributed force more effectively. Spines extended outward, increasing apparent size or creating barriers that complicated direct contact. Some surfaces became ridged or layered, not only adding strength but also altering how a predator might approach or handle the organism. These changes did not eliminate risk, yet they shifted the balance, making each interaction more uncertain and often more costly for the attacker. Behavior followed structure, adding another layer of response. Many organisms reduced exposure by remaining close to surfaces or within spaces that limited access. Reef environments, already complex in form, became places where small movements could carry an individual from openness into shelter within moments. Narrow gaps, overhangs, and enclosed passages provided temporary safety, allowing organisms to navigate between visibility and concealment. The landscape itself became part of the defense, offering positions that could be occupied and vacated as needed. Movement patterns also changed. Some species began to coordinate their motion, forming groups that moved together through the water. In such arrangements, the presence of many bodies created a shifting visual field, making it more difficult for a predator to isolate a single target. The group acted as a collective, not through intention in the human sense, but through shared movement that altered how each individual appeared within the whole. This strategy did not remove danger, yet it redistributed it, reducing the likelihood that any one organism would be selected at a given moment. Other responses unfolded across longer spans of time. Life cycles adjusted, with some organisms reproducing more quickly, ensuring that even as individuals were lost, the population as a whole could persist. Shorter intervals between generations allowed for more rapid adjustment to changing conditions, embedding resilience not only in the body, but in the rhythm of life itself. This approach did not prevent predation, but it balanced its effects, maintaining continuity despite ongoing loss. Within these overlapping strategies, the relationship between predator and prey became more intricate. Each change in defense prompted adjustments in approach, and each refinement in hunting influenced how prey responded in turn. The system did not settle into a fixed state, but continued to shift, guided by the ongoing exchange between pressure and response. What emerged was not a simple escalation, but a network of adaptations, each connected to others in ways that shaped the broader ecosystem. This process can be understood as a quiet negotiation where neither side fully determines the outcome. Predators introduce new forms of interaction, and prey respond with adjustments that alter those interactions in return. Over time, these exchanges create diversity, encouraging the development of new forms, behaviors, and relationships. The presence of risk does not reduce the richness of the system, but contributes to it, driving the emergence of varied solutions within a shared environment. In this way, the Devonian seas carried not only the presence of powerful hunters, but also the imprint of countless responses to that presence. The organisms that lived within these waters adapted in ways both visible and subtle, shaping a world where survival depended on continuous adjustment, and where life persisted through an ongoing balance between challenge and response. Shapes appear that do not settle easily into familiar categories, forms that seem assembled from decisions that no longer guide modern bodies. In the Devonian seas, many vertebrates carried outlines that resist comparison, their proportions and structures reflecting solutions that followed paths now largely abandoned. These were not incomplete versions of later animals, but fully realized designs in their own time, each adapted to a specific way of moving, feeding, and existing within a world that encouraged variation rather than uniformity. Some bodies placed emphasis on the front, expanding head regions into broad surfaces while narrowing toward the rear, creating a forward presence that dominated their silhouette. Others distributed mass more evenly, yet interrupted that continuity with fins or extensions positioned in ways that differ from what is commonly seen today. In certain forms, paired fins extended like supports beneath the body, suggesting a relationship with the substrate that blended contact and movement. In others, fin placement shifted the center of balance, altering how the body held itself within the water. Proportions varied in ways that suggest experimentation rather than convergence. Some fishes carried elongated forms with narrow profiles, while others compressed their bodies laterally, presenting wider surfaces to the surrounding medium. Certain lineages developed thickened coverings across limited regions, leaving other areas exposed, while others combined different textures across their surfaces, creating a patchwork of rigidity and flexibility. Each arrangement reflects a different balance between strength, movement, and interaction, producing bodies that do not align with a single expectation. Even within similar environments, these designs did not resolve into one dominant shape. Instead, multiple forms coexisted, each effective within its own range of conditions. This diversity indicates that the pathways available to vertebrate life at the time were not constrained to a narrow set of outcomes. Rather, the Devonian appears as a period in which many structural possibilities were explored, with different lineages arriving at distinct solutions to similar challenges. Over time, many of these solutions did not continue into later periods. Some lineages left no direct descendants, their forms ending as conditions changed and new pressures emerged. Others persisted in altered forms, their original designs modified through successive generations until they became less recognizable. The bodies seen in the Devonian, therefore, represent not only what existed, but also what did not persist, a record of possibilities that were tested and then set aside. This absence does not suggest failure. Each form that appeared was suited to its moment, functioning within the conditions that shaped it. The eventual disappearance of certain designs reflects shifts in environment and interaction, where different traits became more advantageous. The fossil record preserves these forms as traces of an earlier diversity, offering glimpses into a time when vertebrate life explored a wider range of structural arrangements than is commonly visible today. Within this context, the Devonian Ocean takes on the character of a field of experimentation. Bodies differ not only in detail, but in fundamental layout, suggesting that the underlying rules of form were still being established. The presence of multiple viable designs indicates that evolution had not yet narrowed its course, allowing for a broader exploration of what a vertebrate body could become. As these forms moved through their environments, they contributed to a system shaped by variety rather than repetition. The interactions between them, guided by their distinct structures, created patterns that were themselves diverse, reinforcing the complexity of the ecosystem as a whole. The result is an impression of a world that operated according to principles still in flux, where stability had not yet reduced diversity into a smaller set of recurring forms. Through this lens, the Devonian seas appear as a place of lost designs, not in the sense of disappearance alone, but as a record of possibilities that once existed and no longer do. The bodies that filled these waters carried with them a range of solutions that expanded beyond what is now familiar, leaving behind a history that suggests how varied life can become when its pathways remain open. Within the quiet margins of this crowded sea, some bodies carried a structure that did not draw immediate attention, yet held within it a different kind of potential. These were the lobe-finned fishes, a group defined by the shape of their paired fins, which extended outward on fleshy, muscular bases rather than thin rays alone. The difference appears subtle at first, yet it changes how the fin connects to the body, creating a jointed, weight-bearing form that can press against the substrate or adjust with controlled strength. In motion, these fins did not simply fan or flutter. They moved with a sense of articulation, each lobe containing internal support that allowed for a more deliberate placement and push. This structure provided stability in environments where contact with the bottom or with submerged surfaces mattered, offering a way to navigate spaces that were uneven, shallow, or filled with obstacles. The body could lift slightly, shift, or hold position with a degree of control that differed from forms relying solely on fin rays for movement. Among these fishes, variations still unfolded, with some remaining more closely tied to open water, while others occupied environments where the interaction between body and surface became more frequent. In such settings, the ability to support weight, even partially, offered advantages, allowing the animal to maneuver in conditions where water depth fluctuated or where movement required more than simple propulsion. The fin became not only a tool for swimming, but a structure capable of engaging with the environment in a more direct way. Over long spans of time, certain lineages within this group would give rise to forms that moved beyond the water entirely, connecting the Devonian seas to a future where vertebrates would inhabit land. This connection does not appear immediately within the moment itself. The fishes of this period remain fully part of their aquatic world, shaped by its conditions and interacting within its systems. Yet within their anatomy lies a framework that would later be adapted, modified, and extended into new contexts, carrying forward a structural idea that began in water. The presence of this lineage introduces a broader perspective to the Devonian. While much of the attention rests on the diversity of marine predators and the complexity of oceanic ecosystems, these fishes represent a quieter thread, one that does not dominate the scene, but extends its influence across vast stretches of time. Their significance lies not in immediate prominence, but in the continuity they provide, linking one world to another through gradual transformation. This connection also carries a certain contrast. The Devonian is often remembered for its abundance of aquatic life, for the ways in which vertebrates expanded and diversified within the sea. Yet within that same expansion, the foundations of a different transition were forming, one that would eventually lead away from the water. The structures that supported movement in shallow or variable environments would, over time, be reshaped to function in air, supporting bodies against gravity without the buoyancy of water. In this way, the Devonian holds within it both a culmination and a beginning. It represents a period where marine life reached new levels of complexity, while also containing the early elements of a shift that would carry vertebrates into entirely different environments. The lobe-finned fishes embody this duality, existing fully within their time while also pointing beyond it, their forms bridging two phases of evolutionary history. Seen alongside the more immediately striking inhabitants of these seas, they expand the meaning of the period, showing that its significance extends beyond the presence of large predators or unusual body plans. Within the same waters that supported armored and mobile hunters, quieter structures were forming, setting the stage for changes that would unfold far beyond the boundaries of the ocean itself. Away from the open expanse of the sea, water gathered into narrower pathways and enclosed basins, shaping environments that followed different rhythms and constraints. Rivers traced shifting courses across the land, carrying sediments and nutrients from one place to another, while lakes settled into quieter depressions, their surfaces reflecting a more contained world. Within these freshwater settings, life continued to diversify, and among the inhabitants were forms already familiar from marine environments, including placoderms and other Devonian fishes that extended their presence beyond saltwater boundaries. The transition between marine and freshwater did not occur as a sharp division, but through gradients where conditions changed gradually. As waters moved inland, salinity decreased, currents altered, and the chemistry of the environment shifted. Organisms capable of tolerating these changes could move between systems, occupying new spaces that offered different resources and challenges. For some fishes, this flexibility allowed them to establish populations within rivers and lakes, adapting their behaviors and physiologies to conditions distinct from those of the sea. Freshwater environments introduced a different set of pressures. Space was often more confined, with channels and basins limiting movement compared to the broader marine expanse. Water flow could vary widely, from steady currents in rivers to still conditions in lakes, requiring adjustments in how organisms maintained position and navigated their surroundings. Sediments played a more immediate role, with particles suspended in the water or settled along the bottom, influencing visibility and substrate composition. These factors shaped how fishes moved, fed, and interacted within these systems. Resource distribution also differed. In rivers, nutrients carried from upstream could concentrate in certain areas, creating zones of higher productivity, while in lakes, seasonal changes might influence the availability of food. Organisms needed to respond to these patterns, adjusting their feeding strategies and movements accordingly. The presence of vegetation in some freshwater settings added further complexity, introducing structures that could be used for shelter or feeding, altering the spatial arrangement of life within these environments. Predation and competition continued within freshwater systems, though the specific dynamics could vary. The confined nature of these habitats meant that encounters between organisms might occur more frequently within limited space, influencing behavior and strategy. At the same time, the absence of certain marine species created opportunities for others to occupy roles that might not have been available in the sea. This combination of constraint and opportunity contributed to a distinct ecological character where familiar forms operated under different conditions. For placoderms and other fishes, the ability to inhabit both marine and freshwater environments reflects a broader adaptability. Their presence in rivers and lakes indicates that their structural and functional traits could be applied across a range of settings, allowing them to extend their influence beyond a single type of habitat. This distribution suggests that the characteristics that define their success were not limited to specific conditions, but could be adjusted to suit varying environments. The expansion into fresh water adds scale to the story of the Devonian. It shows that the diversification of fishes was not confined to one domain, but extended across multiple interconnected systems. The same period that saw complex marine ecosystems also supported the development of life within inland waters, linking these environments through shared lineages and evolutionary processes. Within the broader narrative, freshwater settings provide a complementary perspective, highlighting how organisms responded to different constraints while maintaining continuity with their marine origins. The presence of armored and other fishes in these environments reinforces the idea that the age of fishes encompassed a wide range of habitats, each contributing to the overall pattern of diversification that defined the Devonian world. Light settles unevenly across the water, not in a single wash, but in soft bands that shift with the surface above, touching some forms while leaving others in a muted glow. Within this layered illumination, the Devonian Sea reveals itself not through a single movement, but through many, each unfolding at its own pace, each contributing to a wider stillness that holds them together. Nothing here exists in isolation. Every surface, every body, every motion is part of a larger arrangement that fills the water without crowding it, creating a sense of presence that is constant yet unhurried. Reefs rise in quiet complexity, their surfaces alive with small adjustments that continue without pause. Corals extend outward in subtle growth, stromatoporoids add their layered mass, and algae bind the edges where light lingers longest. Within their openings, brachiopods rest in place, shells parting and closing in steady rhythm, while trilobites pass slowly along the contours, their segmented bodies tracing paths that have no fixed beginning or end. Crinoids lift themselves into the water, their arms spreading gently, catching what drifts by, adding vertical motion to a scene already filled with quiet activity. Above these structures, the water carries its own inhabitants. Ammonoids move through the open space, their coiled shells turning with a controlled balance, rising or settling with minimal effort. They drift and adjust, their motion guided by changes too subtle to see, occupying positions that shift with time rather than with place. Around them, other swimmers pass, their bodies responding to currents and to one another, forming patterns that appear and dissolve without leaving a trace. Among these movements, armored fishes cross the scene with a different kind of presence. Their forms hold a solidity that contrasts with the softer outlines around them, their forward structures catching the light as they pass through it. They do not rush. Their motion carries weight and direction, each movement measured, each turn unfolding over a longer arc. When they pass near the reef, the structure frames them, creating brief alignments where body and environment meet before separating again. Along the bottom, sediments drift and settle, particles descending through the water and coming to rest among shells and skeletal fragments. The surface below is not smooth, but composed of accumulated forms, each layer built upon what came before. Small disturbances lift these particles again, carrying them a short distance before they settle once more, creating a slow exchange between water and ground that continues without interruption. The water itself becomes a medium of connection, linking each of these elements without drawing attention to its role. It carries light, movement, and matter, allowing interactions to occur across distance and depth. A shift in one place sends a subtle signal into another, connecting organisms that do not meet directly. This continuity holds the scene together, giving it a sense of coherence that does not depend on uniformity. Within this crowded sea, space remains. Movement flows around structure, between bodies, through openings that appear and vanish as forms shift. Nothing presses against anything else for long. Instead, each element finds its place within a shared arrangement, adjusting as needed, maintaining a balance that persists through constant change. The Devonian here becomes less a moment of action and more a sustained presence, a panorama of life that unfolds without urgency. The forms within it do not demand attention, yet together they create a scene that feels complete, where structure and motion exist in quiet continuity, shaping a world that is both full and at ease within itself. Change does not always arrive as a visible rupture. It can begin as a slow alteration in the background conditions that sustain a system, subtle at first, then more persistent, until the balance that once held steady begins to shift. In the later stages of the Devonian, signs of this kind of change began to appear across different parts of the marine world, not as a single event, but as a series of environmental adjustments that accumulated over time. The sea remained full, its structures intact, its inhabitants still present, yet beneath that continuity, the conditions that supported it were becoming less stable. One of the most telling indicators lies within the sediments themselves. In certain layers, dark bands of rock formed, now known as black shales, which record periods when organic material accumulated under conditions where decay slowed and oxygen was limited. These deposits suggest that parts of the ocean experienced reduced circulation or changes in chemistry that restricted the availability of oxygen in the water. Such conditions do not immediately remove life, but they alter what can persist, favoring some organisms while placing others under increasing stress. Low oxygen environments spread unevenly, affecting different regions in different ways. In shallower areas, where exchange with the atmosphere could occur more readily, conditions might remain more stable, while deeper or more enclosed waters experienced greater depletion. Organisms adapted to well-oxygenated settings faced a narrowing of suitable habitat, their movements constrained by the need to remain within zones where respiration could be maintained. The distribution of life began to shift, not through direct removal, but through gradual restriction. At the same time, sea levels did not remain constant. Fluctuations in the height of the water altered the extent of shallow marine environments, expanding or contracting the spaces where many organisms lived. When sea levels fell, areas that once supported diverse communities could become exposed or transformed, reducing available habitat. When they rose, new regions were flooded, yet the transition itself introduced instability as conditions changed faster than some organisms could adjust. These shifts did not occur in isolation, but interacted with other changes, compounding their effects. The combined influence of these factors introduced a different tone to the marine environment. Systems that had supported sustained growth and diversity now faced pressures that limited continuity. Reefs, which depended on stable conditions for their construction and maintenance, became more vulnerable as changes in water chemistry and level disrupted their balance. Organisms that relied on consistent conditions found themselves adjusting to variations that could alter feeding, reproduction, and survival over relatively short spans of time. Despite these changes, the ocean did not immediately empty. Life persisted, and many forms continued to move, feed, and reproduce within altered conditions. The appearance of stability remained in many places, masking the underlying shifts that were gradually reshaping the system. This coexistence of continuity and change reflects the nature of environmental instability, where transformation unfolds across overlapping timescales, some visible, others embedded within the structure of the environment itself. The richness of the Devonian seas, built through long periods of expansion and diversification, carried within it a certain vulnerability. Systems that depend on multiple interconnected elements can be sensitive to changes that affect those connections. When oxygen levels shift, when sea levels fluctuate, when conditions vary across regions, the balance that supports diversity becomes more difficult to maintain. The very complexity that allows for richness can also introduce points of fragility. In this unfolding, the Devonian does not lose its character all at once. Instead, it begins to change in ways that suggest a transition where the conditions that once supported abundance are gradually altered. The first signs of trouble do not announce an ending, but they mark a shift, a movement away from stability toward a state where the future of the system will be shaped by forces that are already in motion. Breath, in the ocean, is not drawn in and released as it is on land, but held in solution, carried within the water itself, moving silently through currents and layers, sustaining life without being seen. When that supply begins to thin, the change does not announce itself with sudden absence, but with a quiet reduction, a narrowing of what can be supported, a gradual withdrawal that reshapes the conditions of existence. During parts of the late Devonian, this reduction deepened into hypoxia and, in some places, anoxia, where oxygen became scarce or nearly absent, altering the sea from within. In oxygen-rich waters, movement and exchange proceed with relative ease. Organisms breathe through gills, drawing dissolved oxygen across delicate surfaces, maintaining the processes that sustain motion, growth, and interaction. When oxygen levels fall, this exchange becomes more difficult. The same movements that once supplied sufficient oxygen begin to yield less, requiring more effort for diminishing returns. Active swimmers, dependent on continuous intake to support their motion, encounter limits first. Their ability to sustain activity reduced as the water offers less with each passing flow. As conditions shift further, the effects extend beyond individual organisms. Communities that rely on consistent oxygen availability begin to contract, their distributions confined to areas where levels remain sufficient. Regions of lower oxygen become zones of avoidance, not through visible barriers, but through physiological constraint. The space available for life narrows, compressing interactions into smaller areas, increasing competition, and altering patterns of movement across the environment. Reef systems, dependent on the steady functioning of many interconnected organisms, prove particularly sensitive to such changes. The organisms that build and maintain these structures require stable conditions to continue their growth and exchange. As oxygen declines, Their capacity to sustain these processes weakens, and the balance that supports the reef begins to falter. The intricate relationships that allow these structures to persist become strained, and the framework that once held diverse communities together loses its continuity. At the level of the food web, the reduction of oxygen disrupts connections that depend on movement and exchange. Predators that rely on active pursuit find their abilities diminished, while prey species, also affected, alter their behavior in response. The transfer of energy through the system slows as feeding, growth, and reproduction are all influenced by the availability of oxygen. The network of interactions that once moved fluidly through the water becomes constrained, its pathways shortened, and its dynamics altered. In areas where anoxia takes hold, the effects deepen further. Without sufficient oxygen, many organisms cannot survive, and the composition of the community shifts toward forms capable of tolerating such conditions or toward a reduced presence of life altogether. Organic material that would normally be broken down accumulates, settling into sediments that record these periods of depletion. The water, though still present, becomes less hospitable, its capacity to support diverse life diminished. This transformation unfolds without spectacle. The sea does not empty in a single motion, nor does it fall silent all at once. Instead, it becomes quieter in a different way. As movement decreases, interactions lessen, and the space available for life contracts. The changes occur across regions and depths, not uniformly, but in patterns that reflect the complexity of the environment itself. Within this gradual closing, the Devonian Ocean reveals a vulnerability that contrasts with its earlier abundance. The same systems that supported a wide range of life now respond to a reduction in a single essential element, showing how dependent they are on conditions that remain unseen. As oxygen diminishes, the balance shifts, and the sea, though still present, becomes a more limited place, shaped by the quiet absence of what once sustained it. Where once there had been continuity and growth, there now appears interruption, subtle at first, then increasingly difficult to ignore, as the structures that define these shallow worlds begin to lose their persistence. The reefs, which had accumulated layer by layer through steady biological work, no longer extend with the same quiet certainty. Their surfaces, once active with construction, begin to show signs of unevenness, areas where growth slows or fails to keep pace with the conditions around them. What had been a stable framework becomes a system under strain, responding to changes that reach it from the surrounding water. These reef systems depended on balance, on the steady interaction between organisms that built, bound, and inhabited the structure. Corals, stromatoporoids, and the communities that lived among them required conditions that allowed growth to continue without interruption. As the broader environment shifted, those conditions became less reliable. Variations in oxygen levels, changes in water chemistry, and fluctuations in sea level all intersected within these shallow habitats, influencing their capacity to sustain the processes that maintained their form. The decline does not occur as a sudden disappearance, but as a gradual weakening of the framework. Growth becomes patchy, sections fail to develop, and the coherence of the structure begins to break apart. Openings widen, surfaces erode, and the intricate arrangement that once provided stability gives way to a more fragmented landscape. The reef remains present, but its integrity is diminished, its ability to support a wide range of life reduced. With this loss of structure, the effects extend outward into the surrounding community. Many organisms had relied on the reef not only as a place to live, but as a source of shelter, feeding grounds, and spatial complexity. Brachiopods, trilobites, crinoids, and other inhabitants that once found stability within its surfaces now encounter a changing environment where protection is less certain and resources are distributed differently. The spaces that once offered refuge become exposed, altering patterns of survival and interaction. For swimmers that moved among these structures, the change reshapes movement and behavior. The contours that once guided passage and provided ambush points become less defined, reducing the opportunities that depended on that architecture. The relationship between predator and prey shifts alongside the structure itself, as both adjust to a landscape that no longer supports the same patterns of encounter. The reef had acted as a mediator of these interactions, and its decline alters the terms under which they occur. Sediments begin to play a more prominent role as the biological framework weakens. Without continuous growth to maintain elevation and form, particles settle more readily across the surface, smoothing over details and filling spaces that once remained open. This gradual accumulation changes the texture of the environment, further reducing complexity and contributing to the transformation of the habitat. The reef, once a raised and intricate structure, becomes closer to the surrounding seafloor, less distinct in both form and function. The loss extends beyond individual organisms or isolated interactions. The reef had functioned as a center of activity, a place where multiple layers of life intersected, creating a dense network of relationships. Its decline removes that central framework, dispersing the connections that depended on it. What remains is not an empty space, but a different kind of environment, one that lacks the organizing structure that once brought so many forms together. In this unfolding, the reef can be understood as more than a collection of organisms. It represents a built environment, a marine city formed through biological processes, sustained by cooperation and continuity. As it declines, the change reflects not just the loss of individual components, but the disruption of an entire system of organization. The Devonian Sea, once defined in part by these structures, begins to shift toward a different arrangement, where the absence of that complexity alters the character of the world that follows. For a long span of this age, their presence had felt constant, woven into the structure of the sea in a way that seemed enduring, as if the conditions that shaped them would continue to support them without interruption. The armored fishes had occupied wide ranges of habitat, from open waters to more confined environments, their forms adapted to different modes of movement and feeding, their bodies carrying the distinctive plates that defined their lineage. They were not a single kind of animal, but a broad assembly of related forms, each contributing to a larger pattern of dominance that extended across much of the Devonian. As the later stages of the period unfolded, that pattern began to change. The same environmental shifts that altered reefs, oxygen levels, and the distribution of habitats also intersected with the lives of these armored vertebrates. Their diversity, once expansive, started to contract. Some lineages disappeared earlier than others, their absence creating gaps that were not immediately filled. The variety that had once defined them narrowed, leaving fewer forms to represent what had been a widespread group. By the close of the Devonian, this contraction had reached a point where placoderms, once among the most prominent vertebrates in the water, had largely vanished. At most, only a small and uncertain continuation may have extended briefly beyond the boundary, leaving little trace compared to the richness that had preceded it. The decline does not present itself as a single event, but as a drawn-out process, where reduction occurs across different times and places, gradually leading to the disappearance of the group as a whole. Understanding this loss remains a challenge. The record suggests that multiple factors were involved, each contributing in ways that are difficult to separate. Changes in oxygen levels would have affected organisms with active lifestyles, altering their ability to sustain movement and feeding. Fluctuations in sea level would have reshaped the habitats they occupied, reducing some environments while transforming others. The decline of reef systems would have removed structural contexts that supported certain modes of life. At the same time, other groups of fishes, including those with different body designs, were present and may have occupied roles that shifted as conditions changed. These overlapping influences form a complex picture where no single cause fully accounts for the outcome. Instead, the disappearance of placoderms appears to emerge from a combination of environmental instability and ecological turnover, where the conditions that once supported their success were altered in ways that reduced their viability. The same features that had allowed them to thrive in earlier settings may have become less advantageous as the balance of the system shifted. There is a quiet scale to this loss that becomes clearer when considered against the length of their presence. For millions of years, these armored fishes had been part of the fabric of marine life, their forms familiar within the ecosystems they inhabited. Their removal does not leave a single empty space, but a series of absences spread across different environments, each one marking the end of a lineage that had persisted through much of the Devonian. The transition that follows does not erase the past entirely. Other groups continue, new patterns of life take shape, and the ocean moves forward into a different configuration. Yet the disappearance of the placoderms marks a significant shift, a point where one of the defining elements of this age is no longer present. The sea that remains carries forward the consequences of that change, shaped in part by what is no longer there. In this way, the fall of the armored rulers becomes less a single moment and more a gradual fading, where presence gives way to absence over time. The Devonian closes not with a sudden break, but with a transformation that leaves behind a quieter, altered world, one that no longer includes the forms that had once defined it so completely. What remains after a long period of change is not only shaped by what was lost, but by the traits that allowed certain forms to continue. In the wake of the Devonian transitions, some lineages persisted, carrying forward into later ages, while others, once widespread, no longer appeared. Among the survivors were early sharks and their relatives, whose presence extended beyond the boundary that marked the end of many armored fishes. Their continuation does not present itself as a simple replacement, but as part of a broader pattern in which different designs responded in different ways to shifting conditions. The bodies of these cartilaginous fishes followed a different structural approach. Instead of heavy external plates, their support came from internal frameworks that were lighter and more flexible. This difference influenced how they moved through the water, allowing for sustained swimming with less resistance and potentially lower energy cost. In environments where oxygen availability had become uneven, such efficiency may have supported continued activity where more heavily built forms encountered greater constraints. Movement, in this sense, becomes not only a means of travel, but a factor in persistence. Flexibility extends beyond structure into behavior and ecological range. The lineages that continued into later periods appear to have occupied a variety of roles, from open water movement to interactions closer to the seafloor, adjusting their habits to the conditions available. This breadth does not imply superiority in a single trait, but an ability to function across a wider range of circumstances. When environments shift, such adaptability can provide a buffer, allowing organisms to relocate, alter their feeding, or adjust their activity in ways that maintain continuity. In contrast, the armored fishes, with their distinctive construction, may have been more closely aligned with specific modes of life. Their bodies supported certain feeding strategies and patterns of movement that had proven effective within earlier Devonian settings. As those settings changed, the same features that once provided advantage could have become limiting, reducing the range of conditions in which they could operate effectively. This does not suggest a flaw in their design, but highlights how success is often tied to particular environmental contexts. Ecological opportunity also plays a role in what follows periods of disruption. As some groups decline or disappear, the spaces they occupied become available for others to use. The survivors encounter a landscape altered not only by environmental change, but by the absence of former participants. This creates conditions in which new arrangements can form, where existing lineages expand into roles that were previously less accessible. The continuation of sharks and related fishes may reflect, in part, this opening, where persistence combines with opportunity to shape future patterns. The differences between these groups resist simple explanation. No single factor accounts for why one lineage endures while another fades. Instead, the outcome appears to emerge from the interaction of multiple elements, including body design, ecological flexibility, environmental change, and chance events that influence survival across different regions and times. The complexity of this interaction makes it difficult to assign a singular cause, reinforcing the idea that evolutionary outcomes are often the result of layered processes rather than isolated factors. Within this comparison, a broader reflection begins to take shape. Strength, as it appears in one context, does not guarantee continuation in another. The qualities that define success are not fixed, but depend on the conditions in which they are expressed. As those conditions shift, the balance of advantages changes, allowing different forms to persist while others do not. The Devonian thus leaves behind not only a record of what was present, but an example of how life responds to change. The endurance of some lineages, alongside the disappearance of others, illustrates a process that is ongoing, where adaptation, variation, and circumstance combine to shape the continuity of life across time, leaving traces that connect past and future through the forms that remain. Long after the forms of that age receded, their influence continued, carried forward not as a single lineage, but as a set of changes that remained embedded in the structure of life. The Devonian did not end by erasing what it created. Instead, it left behind a reworked ocean, one whose patterns, relationships, and possibilities had been altered in ways that would persist into the eras that followed. What remains is not a direct continuation of every form, but a continuity of systems shaped during that time. The diversification of fishes stands among the most enduring of these legacies. By the close of the Devonian, multiple lineages had already established distinct ways of moving, feeding, and occupying space within the water. Ray-finned fishes, with their lighter frameworks and flexible fins, would continue to expand in later periods, becoming one of the most widespread groups in modern seas. Lobe-finned fishes, though fewer in number today, carried a different significance, their anatomy linking them to a transition that would extend beyond the water itself. The foundations for these paths were laid during the Devonian, where variation in body design and ecological role had already taken hold. Marine food webs also retained the imprint of this transformation. The rise of active swimmers, the expansion of predatory strategies, and the increasing complexity of interactions between organisms did not vanish with the loss of certain groups. Instead, these patterns continued, shaping how energy moved through the ocean. The relationships between predators and prey, between movement and detection, between structure and behavior, all carried forward elements that had been intensified during this period. The reef story, though marked by decline, also contributed to what followed. The collapse of Devonian reef systems altered the trajectory of reef building, leading to a gap before new forms of reef construction emerged in later ages. Yet the concept of a biologically built structure, a place where organisms collectively shape their environment, remained a recurring feature of marine life. The memory of those earlier systems persisted in the way later reefs formed, even as the specific organisms involved changed. Ammonoids, which had appeared during the Devonian, continued their presence into subsequent periods, diversifying into a wide array of forms. Their coiled shells and capacity for controlled movement through the water became part of the evolving open ocean, contributing to the layered structure of marine ecosystems. Their persistence reflects how certain innovations, once established, can extend across long spans of time, adapting to new conditions while retaining their core design. Perhaps the most far-reaching legacy lies in the lineages connected to later vertebrate history. Among the fishes of the Devonian were forms that would eventually give rise to animals capable of moving onto land, linking the marine world to terrestrial ecosystems in a way that would reshape life on Earth. This connection does not dominate the Devonian itself, but it remains present as a quiet thread, a continuation that extends beyond the boundaries of the ocean. The disappearance of the armored fishes does not diminish this legacy. Their role in shaping the conditions of the Devonian contributed to the broader patterns that endured. They participated in the development of complex ecosystems, in the intensification of interactions, and in the diversification of vertebrate life. Their absence marks a change, but the structures they helped influence remain embedded in what follows. In this sense, the Devonian can be understood as a period whose effects extend beyond its own duration. The ocean that exists afterward carries within it the results of earlier transformations, its present shaped by processes that unfolded long before. The forms may differ, the specific inhabitants may change, but the underlying patterns continue, reflecting a past that remains active within the present, as if the sea itself holds a memory of what it once became. Before the outlines of the modern ocean settled into their familiar forms, there was a time when its character was still being shaped, when the possibilities of vertebrate life in water were unfolding in ways that would leave lasting marks. That earlier sea carried bodies unlike those that move through it now, forms built with armor, guided by new kinds of jaws, moving through environments that were themselves changing in structure and complexity. It was not simply a different cast of life, but a different stage in how the ocean learned to function. Across that span, reefs rose and spread, creating spaces where countless organisms found places to settle, feed, and interact. These structures were not static, but living frameworks, growing and adjusting as the conditions around them shifted. Within and above them, movement expanded, no longer confined to the seafloor or to passive drifting, but carried into the water itself by swimmers that explored new ways of navigating and surviving. The sea became layered with activity, its depths and shallows connected through patterns of motion and exchange that had not existed in the same way before. Jaws, once an innovation, became part of the fabric of this world, allowing animals to engage with one another through new forms of interaction. Feeding, defense, and competition all took on different qualities as a result, shaping relationships that would persist in altered forms long after the Devonian had passed. The presence of armor, too, reflected a response to these pressures, a way of inhabiting a world where contact carried greater consequence. Together, these developments did not remain isolated features, but combined to influence the direction of life within the ocean. The Devonian stands, not as a distant curiosity, but as a formative interval, a time when many of the dynamics that define marine ecosystems were intensified and expanded. The diversification of fishes, the restructuring of food webs, the emergence of new ecological roles, and the connection of marine life to future terrestrial lineages all trace back, in part, to this period. Even where specific groups vanished, the conditions they helped create continued, shaping what came after in ways that are still present. The ocean that followed did not forget this past. Its patterns carry forward elements that were established then, even as the organisms themselves changed. Movement through open water, the interaction of predators and prey, the presence of built environments, and the adaptability of life across different conditions all reflect a continuity that links the present to that earlier world. The differences are clear, yet beneath them lies a shared structure, a set of relationships that began to take form during the Devonian. In considering this earlier sea, the sense of distance begins to soften. What appears separated by vast spans of time reveals connections that remain active, shaping the systems that exist today. The forms that once dominated have faded, but their influence persists, embedded in the ways life continues to organize itself within the ocean. If one moment or one creature from this time remains with you, it becomes part of that continuity, a small link between past and present. There are many such moments to notice, each offering a glimpse into how different the ocean once was and how much of that difference still resonates. If you would like to continue exploring these deep time stories, you can follow along as more of these histories unfold. The sea has never been a fixed place. It has always been older, stranger, and more alive than it first appears.